In question 11a, you're asked to find the length of the ladder. Now, the secret to solving questions like this successfully is to draw a neat, ruled, sensible diagram. So immediately, the eyes are drawn to the hypotenuse. It's the sine ratio, so sine of 54 is equal to 5 over h, or h is equal to sine 5 divided by sine of 54. Now, using my calculator for that, so the keyboard will bring up the sine. Make sure you're in degrees. And you can see there, and I don't want a standard answer in this instance. I end up with 6.18 metres. So a couple of things to watch. Your calculator can work in standard notation. It can also work in, as you'll see later on, radians. So make sure it's in degrees for this particular problem. Now, a little trap in doing 11b, you do have to work out the distance that the ladder was out from the wall, because what's happened there is it's going to be minus 0.5 metres closer in. We know the ladder length, but we can't go ahead and find theta or this distance y unless we have a second fact known about the ladder. So I'm going to use Pythagoras's in order to work out what x squared is. So 6.18 squared minus 5 squared. So end up with 13.1966, and that will give me 3.63 for my x figure. Now, if I was to move that 0.5 metres closer, that therefore becomes 3.13 metres as my base length. I've got an angle and I've got the height there. So I can now proceed to find the new vertical height y. So y in this instance, 6.18, or 6.18 squared minus 3.13 squared. Just quickly on my calculator. .4, and the square root of that gives me 5.33 metres. Now, to find theta, I can use any of the ratios. I tend to use the ones I started with, so I'll use the cos theta ratio. So cos of theta is 3.13 divided by 6.18. And I'll put that into my cos to the minus 1, or r cos. So cos to the minus 1 on our calculator. That will give me 60.8 degrees. Please notice that if you've carried through one less decimal place than I have, or maybe a little more, your answer will be close, but maybe not exactly the same as listed in the back of the book. Take some time to look at it. The big trap was I had to find x first, or the distance it was out from the wall, before I could realise it had been pushed in and work it through further.